Madame Wu said, Beta decay was like a dear old friend. There would be always a special place in my heart reserved especially for it. Madame Wu was a woman scientist who contributed a lot in understanding the nature of beta decay. In this video, I will introduce you to what is beta decay and Pauli's neutrino hypothesis. When a radioactive nuclei gets excited, it counts down by emitting some radioactive rays, and this nuclear reaction we call it as a decay reaction. So the decay reaction may be an alpha decay, beta decay, or a gamma decay. What is beta decay? A portion of the radiation emitted from a radioactive source that gets strongly deflected by a perpendicular magnetic field was termed as a beta radiations. And how can we differentiate a beta ray from an alpha ray? The beta rays are very easily distinguished from alpha rays by their greater range in matter. And what are the ways this beta decay can happen? There are three modes of beta decay. One is the negatron emission, that is the emission of an electron, and positron emission. The third method is capture of orbital electrons by protons. We can represent these three modes of beta decay by a nuclear reaction. The neutron transmutes to a proton with the emission of an electron and an antineutrino, and the positron emission can be represented by the proton transmutes to a neutron with the emission of a positron and a neutrino, and the proton captures a positron to give out a neutron plus neutrino. This is the capture of orbital electrons by atomic nucleus or a proton. So out of these three beta decay modes, the emission of negatron, that is emission of an electron particles, is much more common than the other two processes. So all these three nuclear reaction emphasizes that the proton and neutron can be treated as different states of a single particle known as a nucleon, and the electrons plays a photon-like role here. So when a negatron emission happens, the radioactive elements, when it emits a beta particle, the atomic number of the parent nucleus is increased by 1 unit and there is no change in the mass number. When a positron is emitted, the atomic number of the parent nucleus reduces by 1 unit and the mass number does not change. Then the capture of orbital electron by proton can take place. When the ratio of the neutron to proton is low, then there is a greater chances of capture of orbital electron by proton may take place. Next, let's see what is Pauli's neutrino hypothesis. When a beta particle is emitted, they do not have a consistent energy. They have a different energy varying from 0 to a maximum. So to account for this, during a beta decay, scientists struggled a lot. So to put an end to this, Pauli has proposed this theory. A neutrino hypothesis was actually developed by Wolfgang Pauli in 1930. So during a beta decay, the laws of conservation of linear momentum and angular momentum are not conserved. To make these laws of conservation of linear momentum and angular momentum valid in beta decay, this hypothesis was proposed. Firstly, Pauli called these particles the unknown particle, that the particle which he suggested as in ghost particles, and it was hypothetical. So, until they are experimentally discovered by Reines and Cohen in 1956. So, actually, they are not present inside the nucleus. These suggested unknown particles are not present inside the nucleus, they are created when beta decay happens. So, the unknown particle, he named it as a neutrino, and he suggested it carries no charge and ignorable mass when you compare it with the mass of the electron. And he also suggested this particle should be a fermion particle with a spin half and obeys Fermi-Dirac statistics. And it also has its an antiparticle called antineutrino. And antineutrino is also a particle which has a zero charge and mass equivalent to neutrino. That is the negligible mass when you compare it with the mass of the electron. But in the neutrino, the spin and the angular momentum vectors are in the opposite direction. While and in the antineutrino, the spin and the angular momentum vectors are in the same direction, that is parallel to each other. This is the only difference between the particle and antiparticle of the neutrino. The spin and the angular momentum vectors direct themselves in different directions. These neutrinos, after proposed by Pauli, they had a great role in astrophysics for understanding the hidden mass of the universe. Actually, we can say by studying the beta decay, uh, mm, it has given a greater knowledge in understanding the weaker interaction that exists in the universe. So, the electron, neutrino, and the product nucleus share among themselves the energy, momentum, and angular momentum available in the nuclear transitions. So, when the neutrino is emitted with a zero momentum, the beta particle gets maximum energy. So, based on the amount of energy a beta particle comes out, the neutrino carries the left out energy. This is how Pauli was able to make the conservation laws valid in beta decay.